Hi everybody. So in this video, I'm going to show you how we approximate solutions by rounding to one significant figure. So if we look at question A, we've been asked to approximate 213 divided by 0.418. So when we approximate this, we round each of these values to one significant figure. If you're not sure how to do that, you should check out my previous video. I'll leave a link in the description below. So in this 213 becomes 200. This 1 does not round that 2 to a 3 because it's less than 5. And then we dividing this by 0.4. Again, the 1 doesn't round the 4 to a 5. So our approximation is 200 divided by 0.4. And the easiest way of working this out is to convert that 0.4 to an integer. So we can multiply it by 10. Then we'll use equivalent fractions and we'll do the same to the numerator. And this becomes 2000 divided by 4. And when you divide 2000 by 4, we get 500. So what we say then for part A is that 213 divided by 0.418 is approximately, this symbol here means approximately 500. So for part B, again, we'll round each of these numbers to one significant place. So 579 becomes 600. And this 7 does round the 5 to a 6, plus the 6, it does round the 7 to an 8, so plus 800 divided by 100. We can work out our numerator as 1400 divided by 100, which gives us 14. So this is approximately equal to 14. Perhaps you want to try and approximate questions C and D yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you're ready to go. So the 83.5 becomes 80. The 12.8 becomes 10. And then the 0.52 becomes 0.5. So now we have 90 divided by 0.5. Again, we'll use equivalent fractions. Multiplying the 0.5 by 10 gives us 5. We'll multiply the numerator by 10. And then we have 900. And 900 divided by 5 is 180. Question D. The 11.78 we approximate to 10. The 77.8 we approximate to 80. And the 39.4 we approximate to 40. Our numerator, 10 times 80 is 800. Divided by the 40. We can simplify this fraction, divide both by 10. So we get 80 over 4, which is 20. This is approximately 20. Okay, let's try some exam style questions. Okay, so we're told that Taylor has a garden in the shape of a circle of radius 8 meters. And she's going to cover the garden with grass seeds to make a lawn. And the grass seed is sold in boxes. Each box of grass will cover 36 meters squared of garden. And Taylor wants to cover all the garden with grass seed. For part A, work out an estimate of a number of boxes Taylor needs. And then for part B, explain whether your estimate is an underestimate or overestimate. So the first thing we need to do is to work out the area of this circle. We know the formula is pi r squared. And we know the radius is given as 8 meters. So the area will be pi times 8 squared. The 8 squared we don't need to approximate. We can work this out as 64 times pi. And this is in meters squared. but we know pi is approximately 3.14. So it is this value which we need to round to one significant figure. We'll round this to 3. So the area, we can round the 64 to one significant figure as well. This will be 60 multiplied by the pi approximated to 3. This will be meters squared. 60 times 3 is 180. And then we're told each box of grass seed will cover 36 meters squared. So we need to divide the 180 meters squared. We can round this 36 to one significant figure. This will become 40 meters squared. Meters squared will cancel. We can simplify 180 over 40 by dividing by 10. So 18 over 4 or 9 over 2. So this will be 4.5. But clearly we can't purchase half a box. So we'll need 5 boxes. Then for part B, is your estimate under or over? Well, we can see here we rounded this 64 to 60 and we rounded the 3.14 to 3. So in both cases, we rounded these numbers down. And yes, we did round up the 36 to 40, but rounding down the 64 and the pi is more significant. So we'll say this is an underestimate as we rounded down the 64 to 60 and the pi to 3. Okay, let's try one more question. Okay, so in this question, we're told that a cycle race is 2,834.3 miles in length, and Daniel knows his average speed for his previous races is 14.12 miles per hour. For the next race, he will cycle 8 miles per day. Estimate how many days Daniel will take to complete the race. And then for part B, Daniel trains for the race. The average speed he can cycle increases. It is now 15.8 miles per hour. How does this affect the previous answer? So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you're ready to go. So I'm just going to highlight the important values. We've got the total length of a race, the average speed, the number of races, and we want to work out how many days to complete the race. So if we approximate each value, we'll approximate the distance of a race as 3,000 miles. We'll approximate the average speed as 10 miles per hour. And we'll leave this 8 as 8 miles per day. So the first thing we want to work out is how far he will travel every day. And this will be the 8 multiplied by the 10. So the distance covered per day will be 8 times 10. So this is 80 miles. And then we want to work out how many days it will take. So this will be the 3,000 miles divided by 80. We can simplify this fraction by dividing both by 10. So this becomes 300 over 8. We can simplify it again as 150 over 4, or 75 over 2. And we can work out 75 over 2 using the box method. 2 into 7 go 3 times with 1 left over. 2 into 15 go 7 times. We'll carry that 1, and that'll be 37.5 days. So we'll round this up and we'll say 38. And then for part B, we're told that the average speed has now increased to 15.8 miles per hour. So this means the total distance covered per day would have increased. So because you're covering more miles per day, the number of days needed will be less. So we'll say the increase in average speed means the number of miles per day increases, so less days are needed to cover the 3,000 miles. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.